Then these last couple chapters that we threw together. Triangles are three-sided polygons. Alright, that's all you need to know about triangles. We're going to do a bunch of stuff. Now remember, a polygon is out of order, but a straight figure, a straight line closed figure. Alright, so no gaps and everything's got to be a straight line. Sides, alright, those are things that connect the corners so that it is a closed figure, so that it is closed. You need those sides to close up the figure. The vertices are the corners of the polygon. So if I went like this, these in red are the vertices. The sides there are in black. And so those are technically the best straight lines I could draw. Now, look at these three, or these four. These are angle classifications. It's a big word. Alright, so acute triangles are all angles are less than 90 degrees. Obtuse, one. You just need one angle that is greater than 90 degrees. A right triangle is one angle is 90 degrees. An equal angular triangle, all angles equal, and all of them are going to equal 60 degrees. So those are angle classifications. Now the next three would be our side. So S-I-D-E class. So equilateral triangle, all sides equal. Now don't get confused when they give you all sides equal. Just pick two sides and set them equal to each other. You don't have to set all three equal to each other. Just put two sides equal to each other. Scalene is when no sides are equal. And isosceles is when two sides are equal. So really, you can just fill in the bubble and pick out what it means. Right? You can do two at a time as well. Triangle sum theorem is that you know that all angles add up to 180 degrees. Exterior angles is an angle. Let's erase this and move it on up. Okay. So exterior angle. Those are going to be angles. An angle on the outside of polygons. In this example, I'm going to do it like this. This is your exterior angle. Now, what you need to know about that is remote and interior. The two interior angles opposite the exterior. So that would be here, X and Y. So they're telling you that X and Y are opposite the exterior angle. And this is my two interior added up equal the exterior. So in other words, angle x plus angle y here is going to equal the exterior. That's what exterior angle from. The two interior add up and equal the exterior. So we talked about that a bunch. So then we have congruent polygons. Congruent polygons just mean we have some of these statements. Okay, so we have like A, B, C, D is congruent to J, K, L, M. So that means every side and every angle are equal in the statement. So in the statement, you should have angle A is congruent to angle J, because those are first in both of their respective categories. So we did a bunch of matching up letters and making sure they're equal. Congruent triangles use 3 letters. Alright, so we'll have to use 3 letters to tell you how they're congruent. Once proved equal, then this corresponding parts of triangles, then whole triangle is equal. So that means once you find out that it's side, 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 then all the angles are equal. So side, side, side would probably be like this, and this, and they just are going to go 1, 2, 3, 1, 2, 3. That tells us side, side, side. Included angle is the angle between the 2 equal sides. So in this one, we have side, angle, side. We have these triangles, triangles. The included angle would be this one in red that I put, because that is between the pair of sides that are equal. So they actually call it an included angle. We just always said side, angle, side, and the angle has to be in the middle, but they like to call it the included angle. So the included side is the same thing. It's the side between the 2 equal angles. So in that one, angle, side, angle, angle, side, angle, it would be something like this. So these 2 angles are equal with that side in the middle. I'm going to go over here in blue. Angle, side, angle would be this type of deal, this type of deal, and then we'd probably do angle, angle, side. So angle, angle, side. So it's the one right after the other. So angle, angle, side. Goes right in a row. Angle, angle, side. 3 in a row. Okay? And so then once you know that 3 of those things match up and are equal, then you know the whole thing is equal. And we're just going to keep going here and try to finish this up. So we have isosceles triangles now. An isosceles triangle, if I draw 2, or if I draw 1, a little bit better than that, you got some labels. So here's what they talk about for isosceles triangles. Okay, first things first. These would be the base angles. Those are the base angles. And notice they are equal. So those are the base angles. This is going to be the base here. You have a vertex. They want this angle up here to be the vertex angle. So the vertex angle is across from the base. Now, the last thing left is going to be the legs. And so these two sides are the legs. So you have two legs and a base for sides. You have two base angles and a vertex. And then just remember, this is across from here, this is across from here. So those angles, those base angles are equal. That makes the legs equal. And then angles in equilateral triangles are always 60 degrees. So just make sure. We did a lot of isosceles problems like this, where these sides are equal. They tell me 50. Well, 180 minus 50 means 130. So you should know that these have to be equal. So if I split 130 in half, they're both 65 degrees. And so that's what you're kind of trying to do with isosceles triangles and angles. So then we're just going to keep moving on to chapter 5, because that was really not covered that well. Triangle inequality theorem tells you that you add two short sides and see if longer than the long side, I guess is what I used. What that means is if I'm giving 3, 4, let's change this up. If I'm given 4, 5, and 7 for the sides of a triangle, 4 plus 5 is equal to 9. 9 is greater than 7, so yes, it's a triangle. That's what you were doing there. The range, if they give me the range of a triangle and they give me 6 and 8, I'm going to do 8 minus 6 is less than x, which is less than 8 plus 6. So that's the 2 is less than x, which is less than 14. So x has to fall somewhere in that range. So that's the range. This Pythagorean theorem is that a squared plus b squared equals c squared. C is equal to the longest side. C has to be by itself and has to be the longest side. So then polygons, we talked a little bit about. Alright, they're on the other one. Closed figures, straight lines. So non-polygons, curved or open. Examples of that, I don't know, would be this little rainbow sea thing. Or possibly you have this box that doesn't quite close. Those are non-polygons. If I look at this, I'm not going to do this for you. Google name of polygons. Okay? 7's hepta. Alright, we did all these yesterday. So you should have them on your blue sheet. And then you can Google 11-sided figure and figure out what an 11 and a 13-sided figure are. Because we did the rest of them in class. So you should have been paying attention. On Tuesday we did almost every other one in class. And then the last scroll of the day, diagonal of a polygon, we actually never talked about that. Polygon sum. So remember, interior sum, that's when you have to do n minus 2 times 180. That's how you're going to fall on interior. Remember, exterior is always 360. That's why it's easier to work with the exterior of an angle. A regular polygon is when all of them have equal side and angle measures. So all the sides, all the angles are equal in a regular polygon. Convex is regular. These are regular polygons. Alright? They just look like parallelograms and stuff like this. However, concave polygons are indented. So if I looked at it, it would look something like this. Those are indented. Parallelograms. Parallelograms. Opposite sides are parallel. That's how it gets its name, parallelogram. So they have to be, opposite sides have to be parallel. Now, as far as properties of parallelograms go, you have opposite sides equal. You have opposite angles equal. You have consecutive angles. Supplementary. So if I drew a figure, here's my parallelogram. So we just said opposite sides are equal. So that's what we got in blue. Check. In green, opposite angles are equal. So this one has to be equal to that one. These two are equal. And grabbing another color here. Where's my purple? Alright. You have to know green and this purple here, the angle A and angle B here. Angle A plus angle B has to equal 180 for it to be supplementary. Diagonals of parallelogram are bisected into two equal pieces. So if I came up here and drew some pair of diagonals in here, right? I looked at that, and I looked at that one. If this one's 5 down here and this is x, x equals 5 there. Because those diagonals have to be cut into two equal pieces as well. Alright, that's all your notes. The rest of it is room for problems that you want for your final. Have a good day.